Okay, so we were discussing this problem of a uncharged conducting cylinder placed in an external electric field along x-axis. So placed in external electric field along x-axis. This is the problem that we were discussing. And we already know that the solution for the Laplace's equation in cylindrical polar coordinates in general is given by this. And also understand that no longer I can write that for a rho like for inside this is the potential or outside this is the potential. Why? Because now you can see that potential in general is given by minus E naught x c, and V is equal to minus E naught rho cos theta plus c. And you see that as rho tends to infinity, that your V would tend to infinity. That implies that not only these terms, but certainly these terms also contribute. Certainly these terms also contribute. So what I will take, I will solve this differential equation. I will solve this differential equation. Okay. Now, I know that as rho tends to infinity, my potential in general would remain as minus E naught rho cos theta plus c. So this is how my potential would remain. My potential would remain as minus E naught rho cos theta plus c. Is that clear? Now, now if I take my rho tends to infinity, this term will go to 0. I'll write it here. So as rho tends to infinity, the term dn upon rho raised to power n would go towards 0. Okay. And only term that will remain is Cn rho n into this an cos n theta plus bn sin n theta. So only term that remains there is, I'll write Cn, I'll write summation. Okay, I'll write n belongs to natural Cn, and this is like rho k raised power n, and then you have this an cos n theta plus bn sin n theta is equals to c minus E naught rho cosine theta. Okay, so understand the term that only n equal to 1 would survive. On comparison, you can see that only n equal to 1 would survive. All the other terms would go to 0. In fact, you will find all the bn's are 0. All the bn's would be 0. Okay, because there is no such sin n term here. So only cos theta term is there. Okay, so people who joined it right now. Okay, so to everyone who has joined us just now, I'm reiterating the problem. The problem that we are doing right now, that if an uncharged conducting cylinder is placed in an uniform electric field along x-axis, and we want to find what is the potential in general for this problem, understand that this and there are no charges contained inside as well as outside, so forget about it. So we know that if that is the case, then there would this particular physical context, the potential can be found from the solution for the Laplace's equation, that is del square v equal to 0. And in cylindrical symmetry, if we write the solution will be of this form. I told that because ln rho is not defined at rho is equal to 0, so I'm not going to consider these solutions. These will be physically unacceptable to consider them. So what I'll do, I'll take these solutions. Okay, the first thing is this solution, and a little bit of discussion we have done on this in the previous lecture. Understand that if your electric field is along x-axis, so your potential can be written as minus E naught x c. This is via this, because I know that potential and electric field are connected via this relation, minus grad V is equal to electric field. And since electric field is along x-axis, so your Vx is equal to minus E naught x plus c. And if you write x as rho cos theta, so this will be eventually, this is how your potential is going to behave. Now, even as a rho tends to infinity, this is not getting 0. So no longer I'm saying you can say that this is your outside potential, this is your inside potential. So like in spherical polar coordinates also, we did this thing. We wrote this as inside potential, this as outside potential, only if your potential becomes 0 as r tends to infinity. But here is not the case, so we'll certainly solve it in more general sense. Okay. So what I'll do, I know that my potential has this term for all rho. So as rho tends to infinity, this will remain the same. So I'm going to write this V is equal to minus E naught rho cos theta plus C. Even as rho tends to infinity, this will remain the potential. But also I know that potential is governed by the solution for the Laplace's equation, and this is also a potential. This is also potential. Like this is also potential. Let us see how does this potential behave as rho tends to infinity. So if rho tends to infinity, this term would go to 0. So what will happen as rho tends to infinity, this potential reduces to this, and I know that I have to equate it by C minus E naught rho cos theta. And on comparison, I clearly know that sin and theta and cos and theta are orthonormal to each other. So what I'll do, I'll simply compare both sides, and I know that only cos theta term is surviving, and for n equal to 1 it is surviving. So only this remains to be the solution. Only this remains to be the solution. Bn would go to 0 because you do not have any sign term on the right hand side. Is that clear or is that not clear? Or should I repeat it all over again? Okay.
Okay.
Okay. So only n equal to 1 term would survive. So only n equal to, okay. And also remember, I'm not writing dn equal to 0. I'm just saying that as a rho tends to infinity, this overall term would become 0. Okay. Are you getting my point? I'm not saying that dn is 0. I'm saying this entire term would go to 0. I hope it is clear. Okay. I hope it is clear. यहाँ तक समझ में आएगी. Okay. Now try to see that what I'll write, only n equal to 1 term would survive. So this is C1 rho A1 cos theta. Okay. And this will be equals to what? It will be equals to C minus E naught rho cos theta. Okay. So if you write this C1 A1 as some one like single one constant, because after all ये Cn और An multiply होके constant बना देंगे, तो let us write it as K, है ना, इसको एक K बोल देते हैं. Let us write An into Cn as some K. So K rho cos theta is there, and it is equal to C1 minus E naught rho cos theta. So I can write that K, which represents your A1 into C1, is simply minus E naught. I will write it as K1 so that you don't get confused. Okay. So K is minus E naught. And okay, is that clear? And there is no such constant terms here, so forget about this. Forget about this. So C must be 0. Okay, so your C must be 0. So there will be no such constant term, because you see that there is no such constant term here. There's no such constant term here. Okay, because n equal to 0, don't say that n equal to 0 रख देंगे तो this will come as 1 and this will be a naught. No, because n equal to 0, this will not remain the solution. Then n equal to 0, the solution is C naught plus D naught ln rho. Okay, are you getting my point? So K1 is minus E naught. This is very much clear, and you should remember that your K1 is nothing but it is equals to C1 into A1, so that you don't get confused. I'm just writing it all over here. Is that clear? And now we need to find what would be your, like, if only n equal to 1 term is surviving, n equal to 1 term is surviving, n equal to 1 term is surviving. So here also D1 we need to find. D1 we need to find. Okay, is that clear? Or is that not clear?
Yes.
Okay, so what we are going to find, we want to find D1. Okay, we are going to find D1. So I told you that my surface of a conductor is an equipotential, and I have taken that the surface of cylinder, since it is an equipotential, I have taken the potential to be equal to 0. I have taken the potential to be equal to 0. If I take the potential to be equal to 0, what it will yield me? It will yield me that my this would be 0, or I would say that a C1 R, C1 R, C1 R plus D1 upon R, D1 upon R into this entire thing जो भी चल रहा है A1 जो भी था यार A1 cos n theta, ये क्या हो जाएगा 0. So irrespective of what theta is, because see, wherever I go on the surface, my potential should be same. So irrespective of theta, my potential should be 0. Why I'm taking 0? If I would have taken it phi, then the answer would be C1R plus D1R is equal to phi. So that will create a mess overall. So there will be again a difficulty. So why not take potential to be 0? Because I know that my potential is after all a reference dependent thing. So overall, I've taken V to be 0. to simplify the case, if I take v equal to 0, irrespective of theta, wherever I want to go, my potential should be same. Like it should be 0 overall. So this is the condition from the equipotential condition for the conductor. On the conductor, the surface of the conductor is an equipotential. So I've taken the potential to be 0. So irrespective of theta, this particular thing should be 0. Whatever theta may be, your potential is 0. Like wherever you move on the surface, your potential should be 0. So irrespective of theta, this entire term should be 0. So forget about it. It implies what? It implies your C1 is related to D1, or D1 is related to C1 as uh, uh, this. So your D1 is minus R square C1. Is that clear? And had you taken all other terms, हाँ बेटा बोलो.
सर ये जो सॉल्यूशन है इसमें C1 रो प्लस D1 बाय रो नहीं आएगा क्या?
देखो मेरी बात समझो, रो की जगह हमने R रख दिया ना. We are on the surface. So on the surface we'll take the radius of the cylinder. Okay? मैंने नहीं लिखा है तो प्लीज लिख लो इसको. एक्चुअली मैं क्या जल्दीबाजी में प्रॉब्लम को ढंग से डिफाइन नहीं किया. सो यू टेक दिस सिलेंडर की रेडियस एज रो R सर. ठीक है? इज दैट क्लियर? ओके. एंड ओवरऑल जो बच्चे अभी साल पढ़ रहे हैं एग्जाम के लिए, इतना डेरिवेशन मत करना. इसका एंड रिजल्ट इंड्यूस डिस्ट्रीब्यूशन याद रख लेना. और और मतलब सॉल्यूशंस के बारे में आइडिया रख लेना. मतलब एक सोल्यूशन आता है डाइवर्जिंग जहां हमारा कोई इंटरेस्ट नहीं है, एक सोल्यूशन आता है कन्वर्जिंग जहां हमारा इंटरेस्ट है. तो एग्जाम के हिसाब से आई विल टेल यू व्हाट टू रिमेंबर, व्हाट नॉट टू रिमेंबर. So, for example, when we were doing this spherical polar coordinate case, the same case where electric field was E naught k cap and our sphere was placed in it, दो तीन रिजल्ट्स हैं उसके अंदर, वो याद रखना है. इलेक्ट्रिक फील्ड का रिजल्ट, इंड्यूस डिस्ट्रीब्यूशन का रिजल्ट याद रखना है, सो दैट एग्जाम में यू डोंट हैव टू डू ऑल दीज थिंग्स. बिकॉज सी, if you are very good in mathematics and you have very good hand and you have patience in exam, then you can do all sort of things. अब इसमें एक भी जगह फंस गए, let's say if you forgot that for simplification I want to take b equal to 0, then you are in a complete mess. You'll not be able to identify who kya hai. So that is what I'll say. Okay, had I not taken n equal to 1, had I taken n in general, so this would be cn rn plus dn rn. Again, that would be 0, but I already know that all other cn's are 0. So if all other cn's are 0, then all dn's would be 0. Is that clear? मतलब हम लोग पढ़े ना, यहाँ पे हमने कंपेयर किया था, and we know that only C1 exists. So अगर मैंने यहाँ पे लिया होता C2 R जो भी था R स्क्वायर प्लस D2 अपॉन R स्क्वायर भी लिया होता, क्योंकि सरफेस पे तो अगेन पोटेंशियल 0 ही होगा. आई नो दैट माय C2 इज 0, so this would be 0. So this will give, ये इससे फर्क पड़ ही नहीं रहा. Irrespective of what theta is, your potential should be 0. So this is a regardless term. So this will give you a D2 equal to 0. So in any case, all the other dn's would be 0. Forget about it. Only D1 would exist, and D1 is equal to minus R square C1. Is that clear or not clear? ये समझ में आई बात? नहीं समझ में? देखो हम लोगों ने कंपेयर किया ना, सो कंपेयर करते समय हमने देखा कि हमारा पोटेंशियल कैसा है, माइनस ई नॉट रो कॉस थीटा प्लस सी. नाउ एज रो टेंड्स टू इन्फिनिट, दिस टर्म वुड एनीवे सर्वाइव. आर यू गेटिंग? इट विल बिकम इन्फिनिटली लार्ज, नो डाउट, बट दिस टर्म वुड बी देयर. ऐसा नहीं है कि अब रो टेंड्स टू इन्फिनिटी और पोटेंशियल इज बिकमिंग 0. सो आई विल राइट माय पोटेंशियल एनीवेयर इन द स्पेस इज सी माइनस ई नॉट रो कॉस थीटा. So as rho tends to infinity, also this will remain the form of the potential. But I also know that when I'm solving Laplace's equation, that also gives me a potential, and as I take rho tends to infinite, this will go to 0. Overall, this remains to be my potential. Comparing these two terms, I'll get only C1 would survive, and since C1 would survive, it implies only D1 would survive, and that D1 would be minus R square C1. Is that clear? So this is how now I'm going to write the solution. So now I'm going to write the solution as, so what is the solution? The solution for this particular problem would be potential bit. I will only write, not even this summation, I will only write like only one term. That will be like एक इसका ढंग से देखते हैं, ऐसा करते हैं कि I will write it as, क्या था, Cn into rho की power n plus dn upon rho की power n. Bn terms were all 0, so forget about it. It was an cos n theta. This is how it was, and summation implied. I know that this will only have a solution for n equal to 1. If I multiply a1 into c1, this will give me e minus e naught. So this will be like minus e naught here. Rho plus a1 into d1. a1 into d1 would be what? a1 into d1 will be minus r square c1 into a1. This will be like e naught r square upon rho, and this is into cos theta. So this is your potential as a function of rho and theta. Is that clear? So this is your potential as a function of rho and theta. If you want to put these terms like together, and if you want to write it in more compact form, then it will be, you just take E naught comma naught, and in fact I'll take minus E naught comma naught. I will get rho minus r square upon rho cosine theta. So this is your potential as a function of rho and theta. Is that clear to you? So in cylindrical polar coordinates, if a cylinder, uncharged conducting cylinder, is placed in the uniform electric field along x-axis, then this will be the potential in general in the space. So what is extra that has come? So had the uncharged cylinder not been placed here, the potential would be E minus E naught rho cos theta, isn't it? So खुद देखो माइनस ई नॉट रो कॉस थीटा ही होता है ना टर्म. सो इन जनरल अगर ये सिलेंडर नहीं रखा होता यहाँ पे and electric field was along x-axis, my potential term would be minus E naught rho cos theta. Forget about some constant, forget about it. But overall, the term would be minus E naught rho cos theta. Is that something?
Yes, sir.
Okay. But you see that there is an additional term that has come here. This term. And this is a negative. So this term is generated because of the induced charge distribution. So what will happen? Once you will keep this particular cylinder in the space which is having electric field along x-axis, what will happen? There will be some induced distribution of charge, because of which there will be some contribution in the potential. If ये अगर ये नहीं रखा होता यहाँ पे, तो क्या होता है? Electric field along x-axis होता, आपका potential क्या होता? C1 minus forget about the C1 constant भूलो, but overall इस तरीके का कोई term होता. R dependent term देखो minus E naught rho cos theta होता. अभी क्या हुआ? What has happened? What has happened? So if you think ये C1 क्यों हट गया? Because we have taken additional condition that our potential on the cylinder should be 0. So अगर वो नहीं लिया होता, then some constant term यहाँ पे हमेशा रहता. So I've taken, because we are mostly interested in solution form. So अब ये जो term है, and you can see that this is like it is there, and this term is because of the induced charge distribution on the cylinder inside. Is that clear? So this term is contribution for that. So this is that modification that has been caused. So at times in examination, one may ask that if a cylinder is now placed, what is the modification in the potential? So modification in the potential, then you will write E naught R square upon rho cos theta. Is that clear? तो कभी-कभी एग्जाम में बहुत ज्यादा बड़ी चीज नहीं पूछ जाती, बस इतनी चीज पूछ ली जाती है. And then you are in fix, ये क्या बनाया पूछ लिया. So this is the modification in the potential term that is caused due to the induced charge distribution on the inside of the cylinder. Is that clear? Now electric field, as you know, electric field as you know, so that I'm going to write electric field as you know is given by minus of grad of phi, and that I'm going to write it very straightforward because I don't have time. So you just evaluate this. This will be like minus del V upon del rho cap, and then you can write 1 upon rho del V upon del theta cap. So I think this is something that you can write on your own. So I'm not bothered, but I'll write the expression anyhow so that गलती ना रहे. So electric field would be equals to what? It will be equals to E naught 1 plus R square upon rho square. Cost, I'm leaving it to you as a homework. You kindly इसको check कर लेना. I think it is right, but overall just check it so that तुम्हारा derivative का practice हो. Only you have to do this partial derivative with respect to theta and partial derivative with respect to rho. I think this is very easy to do. This is I'm leaving it to you. Okay, now the most important thing that we need to figure out is what would be the induced charge distribution. What would be the induced charge distribution? So what is induced charge distribution? I know on the cylinder or on the conductor in general, I know that just near the conductor, my normal electric field, the normal component of electric field is given by sigma upon epsilon naught, where sigma is the induced distribution, right? Like induced charge. Is that clear? So what is the normal component? So normal क्या होगा इसके? I know that normal to this, this will be the normal direction, and this direction would come out if I take rho is equal to R. So on the surface, there would be induced distribution, and on the surface, rho would be R, and the normal is this direction. That is the rho cap direction is the normal direction. if you take theta cap direction, theta cap कहाँ होगी? If this is your cylinder, this will be your theta cap direction. Okay, this will be your theta cap direction. Rho cap is normal to the surface. So normal to the surface, your rho cap component would be there. So just see this thing and place rho is equal to R. So your normal component of electric field is simply 2, because if you place R here, so R square by R square is 1, 2 cosine theta. Oh, sorry, E naught भी है. So 2 E naught into cosine theta. And what would be your sigma? Sigma would be 2 epsilon naught E naught cosine theta. If you compare it with the result you got in the spherical polar coordinate system, the induced distribution was 3 epsilon naught E naught cos theta. So ये सारे terms याद कर लो. This will be very helpful for you. Is that clear or is that not clear? ये समझ में आया नहीं है? देखो, just near the surface of a conductor, your normal component is related to the charge density by this term. Normal component on the surface क्या होगा? On the surface, the normal component is a radial component. Is that clear? This is the radial component is normal to the surface. ये दिख रही surface? इसके normal दिख रहा है? तो normal component will be this. At surface, rho would be R, so I place rho is equal to R. So this is like En is equal to 2 E naught cos theta, and I can write sigma is equal to 2 epsilon naught E naught cos theta. Is that clear or is that not clear?
Yeah, clear.
Okay, so I hope we've come to the end of this particular topic. If you want a question that I should give you, if you really want that, so this question I'm giving it to you. This is try to solve this problem. अच्छा, तुम्हारे पास book नहीं होगी. So if I'm saying that instead of this, if I'm saying my charge density, तो मैं करा ही देता हूँ, sigma as a function of phi. So if you see Griffith, instead of theta, he has taken phi. Don't worry about this phi. If phi कोई और coordinate नहीं है, sigma as a function of phi is given as a sine phi phi. A sine phi phi. This is your charge density. Is glued over the surface of an infinite cylinder. इन्फिनिट सिलेंडर समझते हो? इन्फिनिट सिलेंडर का मतलब ये है कि अगर ओरिजिन से देखोगे तो जितना तुम ऊपर जा रहे हो उतना तुम नीचे जा रहे हो. सो बेसिकली क्या होगा? इफ यू आर स्टक एट ओरिजिन, whatever charge density you see on the up, the similar charge density you see towards the down. Okay, तो infinitely long cylinder का मतलब ये होता है. It implies that you're talking that your charges on the cylinder look to you symmetric along z axis. So this, जब भी इस तरीके की लैंग्वेज है ना, over an infinitely long cylinder or इस तरह का कुछ, that implies that if you are seeing from origin, your charge density is symmetric with respect to z axis. So there would be no z symmetry in this. So there would be no z dependence. If there is no z dependence, then whatever solution I wrote above would straightway be applied here. So your charge density is given by sigma phi is equal to a sine phi phi, which is glued over the surface of an infinite cylinder of radius r. We want to find potential inside as well as outside. So I have done these questions in spherical polar coordinates. I will insist that you see these lectures, and I'll continue this thing tomorrow so that at least you get some time. And this is like, and we are coming to the end of this topic, so don't worry about it. So next two big topics are method of images and other one is multipole expansion. Okay. So meanwhile, you just revise whatever I've done. So whenever you have this surface densities glued over a surface, there are two conditions that we make use of. The one is the continuity of the potential, and second one, that the normal component of electric field is discontinuous on the surface. The normal component of the electric field is discontinuous on the surface, and this quantum of discontinuity is given by sigma upon epsilon naught. Okay, so these two conditions you have to use, and the solutions I've already stated. And here you can see that I'm not placing this cylinder in an external electric field. So now you can see that your inside potential can be written as simply this, the first term, that is C n rho n, a n cos n theta plus b n sin n theta. This will be your inside potential. and outside your potential will be governed by dn upon rho n, an cos n theta plus bn sin n theta. So I'm giving it to you as a homework. If you can solve it, fine. If you cannot solve it, leave it to me. And if you have Griffith edition 3, if you have this Griffith edition 3, I don't know now, there's edition 4 also in the market. So I have Griffith edition 3. This is problem number, if you remember, 3.25. 3.25. For all those people who are doing MSc right now and preparing for net examination, I would strongly insist that just do at least if not possible, whatever questions are given inside Griffith, the solution ones. Like जो तुम्हारे को example दे रखे ना Griffith के, at least solve them up. Even if you are not able to solve unsolved ones, fine. उनको छोड़ दो, कोई फर्क नहीं पड़ रहा. But at least solve the unsolved ones. At least solve the solved ones. उनको एक बार जरूर कर लेना. Mostly, it has been a trend in the examination that most of the questions are from there only. So, and that way you will be able to solve one of the good books in the electromagnetic theory also. So, electromagnetic theory, if you want to solve part B questions, you can solve IE Irido. That I'll help you, don't worry. And if you want to solve part C questions, that is a little bit advanced, but whatever I'm teaching right now, you can find them mostly in Griffith inside, like exercise ones, like the ones which are solved. This is from the exercise. This is from the exercise. So this is from the exercise. This is unsolved one. Okay. And if you, even if you find ki unsolved ka kya kare, unsolved, there is a solution manual which is in the internet, so you can download it. So don't worry about it. So there is no such thing which I want to hide as a teacher. I want ki tum khud bade ho gaye ho. If you can solve it, fine. If you cannot solve it, I'll help you out. The only two things I have given you, that these two are the conditions that you need to keep in mind. Also, you need to keep in mind that the solution which contains the log term is no longer going to be your solution. Okay, so your inside, I'll write it here. So if you want to write inside potential, now inside potential will be given by summation. I think this will be like summation an, and then there would be some term like an kya tha apna, rho n, and there was some term an. So यहाँ पे Cn था हमारे केस में, Cn rho n into cos n theta plus Bn sin n theta, where n belongs to natural. So your inside potential is given by this. Acha, n equal to 0 mein, your solution was, I think it was C naught plus D naught ln rho. So since I know that rho would become infinite, rho would not be defined, ln rho would not be defined at rho equal to 0. So I'll forget this. So I can expect a constant also. So I'm just writing a constant. I know that probably this may not be of use, but in general, why to leave this solution? So I've just written it as C naught here. Is that clear? Because if you take n equal to 0 here, cos n theta is 1. So, like, are you getting my point or not getting my point? So देखो, अगर n equal to 0 वाले solution consider करोगे, the radial part would be given by C naught plus D naught ln rho, right? Into an की जगह a naught cos n cos 0 is 1. So overall, this will be some constant. So I've written some constant. What will be potential outside? So potential outside would be given by summation n belongs to natural, and this will be like dn upon rho ki power n, and then this will be like an cos n theta plus bn sin n theta. And there would be some constant, no doubt. So I'm going to write it as some, like कुछ भी बोल दो इसको, let's say C1. नहीं C1 बोलेंगे तो दिक्कत होगी. कुछ नया constant बोल दो, let's say D naught. Okay, D naught भी बोल तो नहीं सकते, पर कोई बात नहीं. अपन ने कोई constant बोलते हैं इसको, right? Is that clear? Now I know that these are my potentials. This is one thing. Now you have two conditions that you have to keep in mind. The first condition is that your potential must be continuous on the boundary. So potential must be continuous on the boundary. That is what I want to say. I want to say that if this is a cylinder of radius capital R, then your potential inside at R should be equal to potential outside at R. This is first condition that you should keep in mind. And second condition is that your normal component of electric field outside minus normal component of electric field inside should give you sigma upon epsilon naught. And if you want to write this normal component, it will be like writing minus del V upon del R outside, just outside the surface, that is R equals to R plus. So for R plus, you have this potential. For R minus, you have this potential. Minus minus plus del V upon del R at R equals to R minus. This is equal to sigma upon epsilon naught, that is A sin क्या था sin 5 so एक काम करो ये 5 लिख लो इसको हर जगह because otherwise you will get confused. So this is your phi only. Okay, so ये theta जो है, Griffith usually writes this not as theta, he writes it as phi. So don't worry about it. So this will be like an cos n phi, bn sin n phi, an cos n phi, bn sin. Are you getting my point? This phi is that polar angle only. So don't worry about it. So these two conditions you have to see. You have to verify these two conditions, and then you have to see what is the value of an and bn, and then you will be able to write the answers to it. Is that clear or is that not clear? यहाँ तक समझ में आया नहीं आया?
आया सर.
Okay, so I hope it is clear. इसको एक बार ढंग से शांति से पढ़ना तुम, ठीक है? इसको थोड़ा ढंग से और शांति से पढ़ना. Only then you will be able to understand. Are you getting my point? ये चीज समझ में आई extra constants क्यों ऐड किए? These extra constants are added because you see, अगर मैं वापस समझा देता हूँ ये भी, अगर यहाँ पे n equal to 1 वाला केस है, n equal to 0 वाले केस के लिए सॉल्यूशंस क्या होता है? C नॉट प्लस D नॉट ln रो, ये तो होता ही होता अपनी जगह, इनटू क्या होता? इनटू सम an sin and theta plus उस तरह के कुछ टर्म्स होते हैं, राइट? इज दैट क्लियर? नाउ आई नो दैट
Yes, sir.
rho equal to 0, this will become in as rho tends to 0, this will go towards minus infinity. Otherwise, at rho equal to 0, this is not defined, so forget about it. So you will only have some constant term. And here also you will have some only constant. Is that clear? So this is what I want to suggest. कि ये दो terms add कर लो, just for the sake. क्या यार, D नॉट मत लिखो, इसको कुछ और लिख लो, C नॉट स्टार लिख लो या C नॉट बार लिख लो, so that कोई confusion ना रह जाए, D नॉट से कहीं वो ना समझ में आए, ठीक है? So C नॉट बार, because at times.
Sir, rho equals to 0.
हाँ बेटा बोलो. Rho equal to. हाँ
rho
बोलो.
equals to 0 पे तो ln rho 1 हो जाएगा.
ln
तो
rho
C
1
नॉट
नहीं
प्लस
होता.
D नॉट हो
ln
जाएगी.
rho 1 नहीं होता. ln rho 1 नहीं होता, गलत बता.
ln 0 1.
ln 1 0 होता है, ln 0 कुछ नहीं होता है.
Okay, sir, sorry.
There is no such thing called as ln 0. See, this is your logarithmic function, है ना? अगर ln rho,
Yes, sir, got it.
अगर ln का 0 पे कुछ e आ जाता, let's say कुछ वैल्यू आ जाता, had it been the case, then e की पावर x भी 0 हो जाता, कचरा हो जाता है, ठीक है? So understand point.
Yes, sir.
Understand the point that these two are inverse functions. Since exponential can never have a zero value, so neither can log be defined on 0. Okay, so this is what I'll be doing. Okay, so this is my suggestion. Try to do like these two things. I mean, I have done enough of these things. You just try to do this thing. If you are not able to do, I'll do it. Don't worry. Second thing, try to listen to all the complex analysis lectures, because soon we are going to do previous year questions there. So वो तुम्हारा एक revision हो जाएगा. Around 30-35 कितने lectures. So those lectures फटाफट से उनको revisit कर लो. Then we'll be doing your NET or GATE or TFR questions, so that you'll get rid of that topic as well. Okay. So I'll meet you tomorrow. And meanwhile, I'm leaving you with this particular problem. I have given you ample amount of hints. You just go and visit these hints. Just put all these values here and just try to find ANs and BNs, and you will be able to figure out what is the potential. Okay. So I hope it is clear. I'll meet you tomorrow.
Thank you, sir.